We are going to dive now into this next lesson to see how at times we are going to have to use methods of long division and synthetic division to help us further factor a polynomial when the general approaches do not work. So for example, if you look at this polynomial that is being asked to be divided by 3x plus 1, if we initially ignored what it's being divided by and just looked at this piece right here, and we tried to do the approach of factoring by grouping and use that approach. So very quickly, let me show you what I mean by this. You don't need to do anything, but the GCF here would be 3x squared. And if I took out a 3x squared, that would leave me with 3x plus 8. And then the second GCF for the second two terms would be a positive 7. And that would leave me with 4x plus 1. So notice our factoring by grouping would not work in this case. The 3x plus 8 is definitely not matching with 4x plus 1. And so this approach of factoring this polynomial would not work. So what's happening is instead what we're going to be doing is, what if they gave us one of the factors? And could we further factor after dividing that given factor out? So first let's practice the method. So let's see if 3x plus 1 indeed is a factor of 9x cubed plus 24x squared plus 28x plus 7. So the first thing I want you to make sure you do is that every single one of the terms is listed from left to right, from highest exponent to lowest exponent. And if there's a term missing, I need you to use the placeholder of a 0. So for instance, I'm pretending here, let's pretend that was not here, okay? So you would rewrite this as 9x cubed plus 24x squared plus 0x plus 7. That's how you would rewrite it if indeed it was missing an x term. But this is not the case with this problem, so let's actually work this problem out. So write down this polynomial with me on your paper. 9x cubed plus 24x squared plus 28x plus 7. And we are going to divide this by 3x plus 1. Okay? Now, if this seems a bit startling, let's take a trip to elementary school and do some basic reminding of how to divide by using long division. So in purple over here, let us look at the number 4,632. And let's divide it by, let's say, let's use 3. Let's keep it simple, okay? So recall the process of division. The first thing you would do is ask yourself, well, 3 goes into 4 how many times? So notice how you didn't look at the entire number. You just looked at this and this number and asked 3 went into 4 how many times? Well, it goes in 1 time. So I'm going to put a 1. And once you answered that question, you multiplied 1 times 3, and you wrote the 3 down, and you proceeded to subtract. And once you subtracted, 4 minus 3 is a 1, you brought down the next number, and you asked yourself again the question, 3 goes into 16 how many times? Well, 3 goes into 16 5 times. That's the closest we can get because 3 times 5 is 15. So you multiplied and then you subtracted again. And then you brought down the next number. And in this case, the next number, which in this case was a 3. And you just repeated that process until you reached to the end. And in this case, we ended up with a remainder of 0. Okay, so this process that you see us doing here is not going to change just because they're polynomials. You are going to proceed the same way. So here's what I want you to do instead. I need you to focus first only on the first term of the polynomial, 3x, and the first term of the polynomial you're trying to divide into, 9x cubed in this case. 9x cubed divided by 3x, if you want to even create a little visual over here at the side, 9x cubed divided by 3x is what? Well, it's 3x to the second power, right? So 3x goes into 9x cubed, 3x squared times. So I'm going to come over here and I'm going to write 3x squared. Now you might be asking, why am I writing it over there? I'm just writing it over there because I'm just keeping all my terms lined up together. That's all I'm doing. There's not a specific place you need to write here. I'm just writing it there to keep it aligned. Okay. So now I'm going to multiply. So 3x squared has to multiply with 3x, and 3x squared has to multiply with 1. And let's go do that. Well, 3x squared times 3x is 9x to the third power. 3x squared times 1 is a positive 3x squared. After you multiply, you are going to subtract. So I need to divide, I have to subtract all, in other words, I need to, let me do this. I need to subtract this entire thing. And if I'm subtracting that entire thing, what I'm really doing is distributing a negative. So distributing a negative causes your signs to switch from positive to negative or negative to positive. So here I go. I'm going to change my positive 9 to a negative because I'm subtracting. And then I'm going to erase this one here because that positive becomes a negative. I'm going to draw my line, and then I'm going to combine vertically. Well, 9x cubed and 9x cubed zero out, and 24 minus 3 is a 21x squared. And then I bring down my 28x. Okay? And now we repeat the process. This time I'm going to just focus on this one, okay? My 3x and my 21x squared. So again, I can come over here on the side, 21x squared divided by 3x. That gives me a 7x. So I'm going to come up here, positive 7x. Now I have to multiply that times that and that times that. So 7x times 3x is 21x squared. 7x times 1 is a positive 7x. Now I need to distribute my negative. 21 becomes negative 21. 7x becomes negative 7x. Combine vertically. That means 21x squared and 21x squared cancel. They should always zero out. 28 minus 7 is 21x. And now I bring down my next and last term, positive 7. And we do it again. Take this 21x and divide it by 3x, and I get 7. So I'm going to put plus 7 and distribute. I'm going to write the answer, 21x plus 7. I am going to distribute my negative, this positive. Now I know every single one of these, it's been positive, but it's just coincidence. And here is my 0 remainder in this case. So this is what you would type as your answer in this particular problem in Delta Math. That would be your final result. Okay. Let's do another one. Oh, and by the way, let us pretend that the remainder was not a 0. Actually, you know what? I think I may have done one down here. Yes. Yes, I will explain that actually. Stand by on the remainder when it's not 0. Okay, synthetic division now. Here is synthetic division. Here's the setup. Okay, so we're doing the same thing we just did with long division, but now we're practicing how to divide using specifically synthetic division. So here is synthetic division focusing. All right, so how do we work with synthetic division? So setting up is the first thing that I want to make sure everybody knows how to do it. Okay, but here's the limits of this approach. All right, when dividing using synthetic division, okay, you have to divide by a binomial. So two terms, a binomial that looks either like x minus some number or x plus some number. So your binomial has to have an x value with a coefficient of 1. I want you to notice here, it's just an x minus a number or an x plus a number. So if you look here at our previous problem, this binomial, okay, 3x plus 1, did not have a coefficient of x that had a 1. And so we could not use synthetic division to divide for this problem. You have to use long division on this one, okay? So the good thing about long division is it doesn't have any restrictions. Synthetic division, students prefer it sometimes because it's faster, but the limitation is that you must have a division by x plus a number or x minus a number like it is right here, okay? So that does allow us to divide by synthetic division, and so let's proceed. So what you're going to do is always verify if your binomial is x plus a number or x minus a number. So why? Because the first thing you're going to do is find your x-intercept, okay? Find your x-intercept. Actually, let me make this a little bit thicker. Hold on one second. Okay, so find, I want to make sure everybody's seeing these instructions. You need to find x-intercept. So just like you've been doing all along, you are going to take your x plus 1, set it equal to 0, subtract 1 on both sides. And so my x-intercept in this case is x equals negative 1. Okay? Once you have found that x-intercept, I want you to come over and in this backward looking L, okay, let's make this, it looks like backwards capital L, okay, with like a 90-degree angle. And this is me being OCD. There we go. I need you to put your x-intercept in there. In this case, negative 1. And then what I need you to do is I want you to get every single one of the coefficients in front of your terms, in front of your x's, including your constant, and you are going to list them right next to that x-intercept. So in this case, we have a positive 2, a negative 1, a negative 1, and a positive 2. So space them out, all right? Again, if you're missing a term, put a 0 placeholder. Make sure you are looking at your exponents, 3, 2, 1, 0. Make sure they're in order, okay? Now that you've lined them all up, leave a little space under those numbers and draw a horizontal line. Okay, let's see. Is that straight enough? Yes, it is. Okay, everything's set up. First thing you'll do, take this number and I need you to bring it down. Okay, bringing this number down exactly as you see it. Don't do anything, don't change it, bring it down. Now, once you bring it down, you are going to multiply. You are going to take this number and multiply it with that number, and then you're going to put it right here, okay? So I'm going to actually draw out the path so that you see it for your notes. You are going to MULT for multiply, and then right here, you are going to ANS for answer. -1 times 2 is -2. And then once you have answered vertically, I need you to combine those terms. So combine. Sometimes you're going to subtract, sometimes you're going to add. -1 and -2 combine to be a -3. And then you just repeat the process. Take -1, multiplies by -3, and you put your answer there. Whoops, wrong pen. Combine, -1 and a +3 makes a 2. And then we do it again. -1 times 2, let me get my little pointer, -1 times 2 is what? -2. Put your answer, -2. And we've reached the end. 2 and -2 makes a 0, and that last number is going to be your remainder. Okay, this here is the remainder. So x plus 1 is indeed a factor of this. This here is an x-intercept or a factor of this polynomial because the remainder was 0. Okay, so how do we write our final result? Well, we need to convert this back into a polynomial expression. So since we divided a x cubed function by an x function, our first term has to be an x squared, because x cubed divided by x cubed divided by x is an x squared. So this too is going to have to be an x squared term. This number is a -3. Has to be then an x, because we're going down by increments of 1 on those exponents. And then the +2 as an exponent of x to the 0. But we all know that x to the 0 is a 1, and 2 times 1 is a 2. So your answer will just be displayed, typed into Delta Math like that. Okay. There you go. So type that in. All right, last problem. We're going to do this one a little quicker, and particularly why we're doing it is because I wanted to show you guys how to write the answer of problems that do have remainders other than zeros. And this is the format that you would use for whether it is long division or synthetic division, by the way. Okay. All right. Me highlighting that seems to have covered everything up, but oh well, it'll be okay. That's bothering me. Hold on. Okay. I'm just not going to cover it. You know where I'm focusing. So let's do this. Let's first take our x minus 4 factor and set it equal to 0 to find our x-intercept. In this case, it is a 4. So I'm going to put the 4 down, and I'm going to put my 4 in a backwards trapped L, right? And I'm going to now write the terms. Now let me double check here. I have a 3, a 2, a 1, and a 0. So it is in order. So let's write 3, space, -17, space, +13, space, +23. Draw the horizontal line, bring down the first term, and we multiply. 4 times 3 is 12. -17 and 12 is a -5. 4 times -5 is a 20. 13 and 20 makes 33. 4 times 33. So let's do this real quick math. 4 times 30 is 120. And then 3 times 4 is a 12. So 120 and 12 is 132. Whoops. So let's combine. 155 is our remainder. So because our remainder now is not 0, we are going to rewrite this and stipulate that it isn't. So notice that we have a 3x cubed that's being divided by an x. That leaves us with 3x squared. Sorry, not 3x squared, with a x squared term. So we're going to have 3x squared minus 5x plus 33. And then we have a remainder of 155. So we're going to put plus 155 over, and I want you to write down what you divided by, and that's x minus 4. So notice your remainder will always be the numerator value, and your denominator will always be the factor you divided by. And so this is what you would type out in your Delta Math as your final answer.